The story of how we feed ourselves is a story of innovation, a constant search for more from less. In vast, sweeping fields across continents, a quiet revolution began with a single, remarkable seed, the hybrid. A hybrid seed is the first generation, or F1, created by crossing distinct pure parent lines to unlock superior performance. Hybrids boosted food security, but their uniform success contributed to the erosion of traditional varieties, or land races. This is a fundamental tension: unprecedented yields versus narrowing genetic foundations. As the global population surged, we scaled production with technology, and with seeds engineered for predictability. But diversity is our insurance policy, each variety a different key to survival. Hybrid vigor, heterosis, emerges when two inbred parents produce offspring outperforming both. Hybrids grow faster, stand taller, and set more grain or fruit. In maize, hybrids historically lifted yields dramatically, often 15–25% or more in modern programs. These gains reshaped farm economics and national food balances. Uniformity is the quiet superpower of hybrids. Plants grow and mature together, enabling precise harvest windows. This predictability allows mechanization to operate at peak efficiency from planting to processing. Parent lines are chosen for pest and disease resistance, stacking protection into the hybrid. Result: fewer losses and, in some systems, reduced chemical reliance. Hybrids can be bred for drought, salinity, and temperature tolerance, traits vital in a changing climate. A hybrid that yields with less water or survives a late frost buffers communities against failure. Higher yield, uniformity, and resilience scale across supply chains, feeding billions. As populations grew, hybrids underpinned reliable surpluses. They are a triumph of ingenuity and management. Standardized outputs enable industrial-scale processing and trade. For many nations, hybrids remain a cornerstone of food security. The success of hybrids came with a steep price: genetic erosion across crops. Millions shifted from local land races to a few high-performing hybrids, narrowing the genetic base. This is monoculture, efficient but fragile. A genetic bottleneck means fewer traits in play when threats evolve. If a new pathogen or adapted pest emerges, uniform crops share the same defense or the same weakness. Without resistant individuals to slow it, failure can cascade like wildfire. History warns us, reliance on uniform varieties amplified the Irish famine's devastation. Today, a synchronized vulnerability spans continents. By contrast, land races and open-pollinated varieties are genetically diverse and locally adapted. That diversity spreads risk. Some plants succumb, others endure. Diversity acts as a natural firewall against total loss. F1 hybrids express their best traits only in the first generation. Saved hybrid seed segregates in F2, losing uniformity and yield. Farmers must purchase annually, exposed to prices and availability set by a concentrated seed market. A few multinationals wield outsized influence over varieties and access. Traditional systems kept stewardship and sovereignty on the farm. But market pressures to maximize yield are immense, especially for tight-margin farmers. In some regions, subsidies and aid are tied to modern hybrid adoption. The choice often pits higher short-term income against long-term independence. The path forward is balance. Keep advancing resilient hybrids while safeguarding genetic heritage. Invest ex situ in global seed banks, libraries of traits for tomorrow's challenges. Support in situ on farms to keep diversity evolving under real climates and pests. Policies and markets that reward stewardship make resilience economically viable. Consider the origin of your food, and support biodiversity efforts that protect our shared future.